All right, welcome to your first video for geometry. What we're going to do in this video is we're going to go through, we're going to look at some vocabulary. That way you don't have to watch your teacher stand in front of you and sound like the Peanuts teacher going wah, 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 wah. Although I just did it, so I guess you get to watch me do it too. So, welcome to geometry vocabulary. I'm going to try and make this as painless as possible. So the first thing you're going to have to do is you're going to follow along with me here. So a point is really the first thing that we have to talk about. And what is a point? Well, a point is a location. Technically, geometers will say that a point is really undefined, but in this case, we like to just call it a location. So what does that really mean? Well, what that means is I can basically draw a point however I want, and it doesn't have length or width or anything like that. It's just a point. So I'm going to call this point P. And a point is a location, and the notation is just one letter. A capital letter. That's point P. Ta-da! Now, a point, and then we have a line. So a line is one-dimensional. That means it just has length. It doesn't have length and width. So if I have a line, it's one-dimensional and it goes on forever. So when I said it has length, it really has an infinite length. It's not a measurable length when it's a line. And when I want to define a line, we can do it in a couple different ways. We can first say, well, I'm going to call this line M. And that's one way to talk about a line. And the other way is to find points on the line. Here's point A. Here's point B. And I could also call that line AB or line M. So the notation for these things would be line M, or we can just say AB with a line with an arrow over the top of it, or I could call it, if I wanted to, BA with two arrows over the top as well. So a line is one-dimensional. It goes on forever in both directions. It is labeled with one lowercase letter, sometimes in cursive, like my M, or two uppercase letters that came from points that were on the line. If there were no points, you could just create them. If there were points, you don't obviously have to create them. So, moving on from there, next, we will talk about a segment. Now, a segment is a piece of a line. It's a measurable part of the line that consists of two endpoints and all the points in between them. So if I wanted a segment, I would have something that looks like this. ML. I don't know, I just made those up. So ML is a segment. I call it ML with a bar over the top, or I can call it LM with a bar over the top. Doesn't matter. But again, we're going to use capital letters because M and L are points on the line. So we've got a line, we've got a segment. Now, what's a midpoint? Well, a midpoint is exactly what you think it is. It's a point in the middle. What do I mean by middle? I mean the exact middle. It cuts it in half. So if I have JK, and that's a segment, and I want its midpoint, I would find the spot right smack dab in the middle. I'll call it M for midpoint, and that's your midpoint. We don't really have a notation for that. It would just be M is the midpoint of JK, with a bar over it because JK is a segment. Now, would a line have a midpoint? I don't know why I'm thinking so long. I know the answer. No, a line doesn't have a midpoint because a line doesn't have a measure, so it can't have a middle. A line goes infinitely in both directions. There's no middle in an infinite direction. So there you go. Now, what about the length of a segment? I talked about a segment. I said it can be measured. The length of a segment is the calculated measure of a line segment. So if I had like JK here, and I brought out a ruler and I measured it, and let's say this thing was, I don't know, 4 centimeters long. The reason I have a whole box for this is when I talk about it, what I really mean is how do you write notation? I would write JK equals 4 cm. But Mrs. Fibber, you didn't put the bar over the J and the K. That's okay. JK doesn't need a bar when you're talking about its length. And that's something that's going to come up a lot in geometry, is that the way that you write things down is really important. Does the bar on top of your letters have arrows? If it does, that means you've got a line. If there's a bar but no arrows, segment. If there's no bar at all, that means we're looking at segment JK, but I don't care about the segment itself. I care about how long it is. I'm looking for a number. So JK without a bar means number, okay? Okay. So, moving on, we have next a ray. So what's a ray? A ray is like pew, pew, a ray gun. It starts at one point and goes in a certain direction, but does not go back in the other direction. It is a line that has one end point and goes on forever in one direction. Now, how am I going to notate that? Well, what I'm going to do for this one is I'm going to call this ray R, and I need a direction for it, so I'm going to call this RS, and I'm going to write it as RS with an arrow going that way. That's it. Okay, I can't write it as SR because that means it's pointing towards R, which this thing is not. So this is ray RS. Okay, moving on a little bit more. Let's change colors just because I'm bored. We're going to go to red next. So next I have the word collinear. Collinear. Co prefix, meaning often with. Collinear with lines. It's something that lies on the same line. So two things are collinear if they are on the same line. Two or more points that lie on the same line. Two or more points that lie on the same line. Collinear, hurrah. So if I had something like this, here's a line, here's A, here's X, here's Q, here's P, and here's R. All those points there are not collinear, but AX and Q are all on the same line, so AX and Q would be collinear, okay? So now, going from lines, there's also this thing called a plane, and a plane is two-dimensional because it has a length and a width. Now, technically, it's an infinite length and an infinite width, but a plane we often draw as a happy little parallelogram. I turned into Bob Ross with happy trees. This is our happy little parallelogram. That's usually how we indicate a plane if we're going to draw it. And we usually get a plane, a cursive letter, and it's a cursive capital letter. I'm going to call that plane P. So a plane is two-dimensional. It extends infinitely. We'll say outward and upward, even though that doesn't really mean anything. And the other thing about a plane that I ran out of room on that line is a plane is defined using 3 points. Plane is defined with 3 points because if I take 3 points, in between them there is space. But Mrs. Fibber, what if the 3 points are collinear? Well, what if you have 3 collinear points? That means that you are not going to define a plane. So we need to have it defined with 3 points that are non-collinear. And I'm sorry I ran out of room there, but I did. So that's a plane, and if I want to define the plane, I could call this plane P. Or if I gave these letters, what letters haven't been used yet? G, H, and I. There's 3 non-collinear points. I could call this plane, why did that line disappear? G, H, I. Ta-da! Okay, and then last on the front of this worksheet, we have coplanar. Coplanar is exactly what you think it is. Collinear meant same line, coplanar means same plane. Except now on a plane, things can be coplanar like lines and points. So points and or lines that lie on the same plane. So if I had like this plane here, this point, this line, this line, this point, this point, this point, all those things in that picture are coplanar. Okie dokie. Moving forward here, we've got a couple really easy ones that you guys probably know, so I'll go as quick as I can here, but I do want to change colors because I'm bored again. Ooh, purple. Purple looks fun. What's a circle? I know what a circle is. It's a big round thing, right? Yep. Now, specifically, although in geometry, a circle is a set of all points that are equidistant from a given point called the center. And they're not just equidistant, they are a given distance away. So if I have a center, we'll call the center O, and I want to have a whole bunch of points that are, let's say, this far away. There's that one, there's that one, there's that one, there's that one, there's that one. These are all the same distance away from O, and if I connect them, ta-da, I have a circle. Circle, distance apart. Now, how do I notate a circle? We usually just call it circle O. You name it with the center. And then if I want a radius, the radius is exactly what you learned about before. It's a segment that connects the center to a point on the edge. Okay, so the radius is half the width of the circle at its widest point. All right, moving from circles into angles very quickly. An angle is really two rays that at one point. So if I have this ray and I have that ray, and let's say I call this, I don't know, what letters haven't been used yet? Let's say R, S, and T. That angle is angle S. And now when you name an angle, you can name it with just the vertex, or much, much better, you can name it with the three letters that form it, R, S, and T. You could always call it TSR as well. You could not call it TRS because R is not the vertex, S is. So the vertex always has to be this middle letter when you name an angle. Easy peasy. All right, what kind of angles do we have? Well, we've got acute, those are teeny tiny cute ones. And then we have a right angle, which is exactly what you think it is. And then we have an obtuse angle, which is the big one. And then last but not least, we have a straight angle, whoop, straight across. So what does it mean to be acute beside it being tiny? Well, acute means this is an angle whose measure is less than 90 degrees. So acute is less than 90. Right is exactly what you think it is, an angle whose measure is 90 degrees. Obtuse is the big one. That's a measure that is bigger than 90. And a straight angle is one with a measure of 180 degrees. So obtuse is bigger than 90, but it's also less than 180. So between a right angle and a straight angle is all your obtuse angles. All right, we just have a couple more, 3 more to go here. So what's reflexive? Well, reflexive is when you go the other way. So if I have like this happy little acute angle, and let's say this angle is 50 degrees, I'm measuring that from here to here. A reflexive angle says, well, what if I didn't want to measure on the inside and I wanted to measure on the outside? This right here would be the reflexive angle, the outside measure of the angle. And that's going to be greater than 180 but less than 360. In this case, it would be 310 because I've got 50 degrees there and 310 all the way back around. Two more, angle bisector. So bisector, what does that mean? Bisect means something has to get cut in half. So if I want an angle bisector, let's go back to this 50 degree angle here. A bisector would cut that 50 right down the middle like that, giving me 2 25s. So an angle bisector is a segment, a line, or a ray that goes through the vertex of the angle and cuts the angle into 2 equal parts. Easy. And I keep talking about 25, 50, 310. What am I measuring? Well, those are measures of an angle. That's a numerical value. The reason this guy gets its own cell in the table is if I want to talk about, say, angle ABC, I would write it like that. That's angle ABC. But if I want to know how big it is, I'd put a little cursive or italic M in front. The measure of angle ABC would be, 42 degrees or whatever it happens to be given your picture. So if I had this angle right here, and this is A and that's B and that's C, the measure being 42 means when I go in here, what's the measure of that angle? All right, so you'll find that all these videos end with a joke because there's nothing Mrs. Vibber likes more, well, except math. Nothing I like more than a really bad joke. So we are going to do bad joke number 1, and I will preface this with most of these I give to my son, who is at this point almost 7. So some of them will be done little kid humor, but you're going to repeat them because they're going to be funny. So, what color is a belch? I'll wait, think about it. What color is a belch? Purple. All right, welcome to Geometry Flipped Lessons. Here's your first one. We are raring to go for more. Have a wonderful evening, morning, daytime, middle of the night, whatever you're doing this. I hope you guys are having a great day. Toodles.